Minecraft, arguably one of the most popular games of all time, has been making a resurgence in a lot of gaming circles over the past year or two. And even though I already made a video about Minecraft and how it performs, I feel as if that video didn't go deep enough into the actual performance, and instead stuck more to the reasoning for the differences. So to rectify this and to properly tackle the subject, let's take another look at Minecraft Java Edition and check out how it performs on a variety of hardware. Alright, so before I dig into the hard numbers, let me go over some differences between the games and actually revise some of the information I discussed in my previous video. I first wanted to address what was commented by RunnyCZ, which reads, the performance difference between Java and C++ is something around 10%, which is almost nothing. Continuing on later with, the real problem with Minecraft Java Edition is the quality of the code, which is a statement that I completely ignored in my previous video. Now, if you're confused by the term quality of code, what he's actually referring to is the efficiency of the algorithms being used. He actually mentions this in part of his comment, and brings up the fact that Bedrock was rewritten from the ground up by a much more experienced team rather than a couple guys programming in their basement. It's not to knock Java Edition, but it's just the facts, and proof of this can be shown on your own system. If we load into a world and fly up, you can see that chunks are loading in radially around the camera, irrespective of whether or not the chunk is actually in view. This can be confirmed by quickly turning the camera, and you'll see the chunks behind you are already loaded in. Bedrock Edition, if we do the same thing, renders chunks with respect to your camera's view, and is shown through turning the camera, and you can see stuff loading in. Optifine is a popular mod that helps performance, and it does so by optimizing chunk generation similar to what Bedrock uses. For example, if you're facing east and your FOV is set to only 90 degrees, that means for 270 degrees, Java Edition is rendering parts of the world that you aren't even looking at. Some of the world's most advanced and optimized rendering engines, such as what's found in Doom Eternal, actually occlude individual vertices in a piece of geometry depending on visibility to the camera. And Optifine and Sodium use a similar technique to squeeze more performance out of your hardware, as well as introducing more graphical switches that you can enable or disable. Imagine you wrote a game when you were a novice programmer. It wasn't much, but you're proud of it because it's a big step forward for you. Now go back and look at it after 8 years of experience, and you'd be able to find tons of little bugs and efficiency hacks that you could iron out. The second piece of information I want to clear up is the fact that Java is a compiled language. It first takes your code and compiles it down into bytecode, which is read by the Java virtual machine. C++ and C are also compiled languages, however the final compiled formats are what differs between a C language and Java. Another commenter actually brought this up, however I'm struggling to find the actual comment they left, however it went something along the lines of, Java is optimized for different use cases and games just aren't one of the intended uses. This is 110% true. And I know this for a fact because I personally have experience using Java-based machines in grocery stores. In fact, I'm sure most of us have, because tons of corporate terminals run using code written in Java. It's more of a language designed to keep track of a massive amount of data, whereas C++ is more optimized for speed of execution and resource control. It overall accounts for less of a gap than I made it seem, however the difference in the underlying tech is still there. Let's move into performance though, and take a look at how Java Edition performs on a variety of core configurations, and try to gauge what you would need to run Minecraft Java Edition smoothly. Alright, so the first thing I did to try and gauge performance was spawn into a super flat world, and just record the average frame rate over the course of 10 minutes. I also logged the recorded frame rates and put them into a graph to show you how FPS fluctuated over time. You can see from this particular run, the game ran excellently, and even though there were some frame drops and rhythmic patterns, for the most part it was stable around the 760 FPS mark. Keep in mind that I'm running Minecraft on an i9-9900K, so this processor should be able to handle the game exceptionally well, and with the render distance set to 32 chunks, this processor delivers stable performance and high frame rates. However, when we move into a randomly generated world, things start to look, well, rough. Keeping our render distance set to 32 chunks, I hopped into a new world in creative and just flew around within Elytra. Performance was honestly kind of rough at times, with our framerate constantly fluctuating and only becoming relatively consistent at around the 470 second mark, only for the erratic behavior to return less than 30 seconds later. To get an idea as to what kind of setup you would need to run Minecraft Java Edition, I also tested on a 6-core 12-thread configuration, which had framerates that were significantly more erratic. Even though the framerate actually looks higher at points, it overall felt slightly worse to play, however was consistent for the most part. This is just an uncapped framerate, so you will feel stutters at times, but it remained playable utilizing 12 Skylake threads. Moving into 4 cores and 8 threads, Minecraft performance was overall depressed, and the erratic spikes in framerate are, for the most part, gone. I also noted that the overall distribution of work seemed to be much more consistent between the cores, whereas before there would be 1 or 2 cores essentially sitting idle, while the other threads sat at around 90 to 100% utilization. This is probably a symptom of the overall lack of multi-threaded processing in Java Edition, and just shows that 4 cores is enough to power through Minecraft. For giggles and grins, I also ran 2 cores and 4 threads, and performance, while technically playable, was suboptimal to the point where it was sort of nauseating due to the hitching. Turning on VSync would fix a lot of the issues, as locking your framerate helps to keep render times consistent. However, with the dips we were seeing into the low 30s, it was playable but not playable. Overall, from the testing conducted, the conclusion seems to be that 4 cores is enough to play Minecraft Java Edition at 60 FPS and above, with hyperthreading offering smoother performance with an overall higher average. 6 cores and 12 threads and above felt the most consistent, which is what you'd find with a modern i5, with 2 cores and 4 threads allowing for playable but suboptimal performance. I would recommend at least an i3 8100 or optimally an i3 10100F if you're looking to start a budget Minecraft-centric build. But if you're looking for ultra-smooth performance, then the i5 10400F would offer you an incredible experience, especially for the price. Minecraft Java Edition, while I made it to be worse than Bedrock, actually has an overall similar but depressed performance profile, centralized around the lack of more efficient algorithms and the overall worse garbage collection of Java. In reality, it's less of an apples to apples comparison, and it's more apples to oranges. They're both impressive games, however, and I'm surprised how much the game has evolved, especially in just the time since I released my original performance analysis video. It's as fun a game as I remember, and I can't wait to see what they bring next to the game that I spent a majority of my childhood building on.